Welcome back to another sunny day in Thailand, and welcome back to the actual implementation and testing of the new solar power system and the monitoring software. This one's going to run a little bit long, so either crank up the speed on YouTube or settle in with a glass of your finest adult beverage, and I'll show you what's going on. Good morning. It's 6:30 in the morning, just after sunrise, and here's our setup. See, the module barely fits. I've got it plugged into the microinverter, coming over into our disconnect and into the grid. We're not making any power yet. I guess we just don't have enough to turn on the microinverter yet. And check that out. We are making power. We're making a watt. 1 watt. And it's gone. Okay, the microinverter is awake, but waiting in standby mode because there's not enough DC power coming through right now. That's what that flashing light says. Okay, it's almost 8 a.m. and we've got ambient light, but we're just starting to get the first real sun on the module. You can see the sun is really trying to come around the corner. And the inverter has flicked green a couple of times and then gone back to standby. It's just not quite enough light to turn the system fully on. It is now 8:30 a.m. We have a very, very tiny amount of direct sunshine on the module. The inverter is working. If you can't see the green LED there, I'm showing flickering between 2.9 watts on the kilowatt, and I'm getting 2, 3, 4 watts on the sawn-off. So our day is starting well. Well, it's 10 a.m. and we've got sun in this area, and we're sitting at around 9 or 10 watts. So it's clear the module needs a substantial amount of sun to actually activate all the internal strings inside. Hopefully this is going to start happening when the sun is much closer to over here. Okay, it's 11 a.m. We've got a lot more sun, but we're still hovering around 6 to 7 watts total power output. It just goes to show the way these cells are wired up, you need full sunshine. Okay, it's noon. We have almost complete sun except for this small triangle here, and we're still sitting at about 10 or 11 or 12 watts. It's bouncing up and down a little bit. Well, it's 1:45 and we just hit the jackpot. The sun is now fully illuminating this last row, and we were down here around 10 or 11 or 12 watts. When the sun hit this last row of cells, we are now looking at a peak of 70 watts, which is not bad considering we're missing all of this shaded stuff and we're at 0 degrees instead of our magic 12.5. Well, it's 1:30 now, and we just popped up another 10 watts. We're at 80 watts output now, and we're just starting to shade this corner from the glass. Okay, it's 2 o'clock. We have shadowing that is affecting this row, and we've plummeted. We are now at 17 watts. So the day is pretty much done for this module, even with this tiny amount of shadings. Welcome to the morning of day 2. The module is now being held up by this plastic pipe system that I made that's holding it at the magic 12.5 degree angle. Looking at it now, it doesn't really look steep enough compared to the angle of the sun, but at 8 o'clock in the morning we're already making 5 watts, so we're getting better pre-full sun power than we did before. But let's see how it works out for the day. Okay, it's 12:15 and we just started ramping up the power because The top of the last row is now in the sunlight. We are at 28 watts. It just popped up, and we're going to see the power go up more. Hopefully we'll get over 80 watts peak because of the angle. All right, it's 10 minutes to 2. We have just gone past peak production because we're getting shading here. We hit 102 watts when the shading was absolutely perfect from side to side. That's just under 1/3 of the panel's rated power at a very compromised angle and with partial shading across the front of it, which is pretty good. So I'm going to let this run for the rest of the day. I'll set up a new racking system and we'll try it again tomorrow in the next step. Okay, here we are on the day of the perpendicular to the sun test. And if you can barely see it right there, let me zoom in. There. See that little dark shape right there? That's it. Camera's not great. It's a lot easier from the road to look at that and say, oh yeah, that's a solar panel. But it's no worse than the chairs and the umbrellas and all the other crap everybody else has. Welcome to experiment 3. Sun is at 51 degrees this way, so we are at 39 degrees that way, perpendicular. We're up and running at 8 o'clock in the morning, and we're making 7 watts. As you can see, the angle is quite steep. We have some sun picking up in the corner yet, but it's going to be a while before we get some good power out of this. Okay, we are just past peak. We're getting some shading from the sunset side. We hit 118 watts, even with all of this shading from the balcony. And beautifully, we've got a very thick and steady curve on the way up, and we're going to get a lot more energy out of this system. We're at peak, and we've already done 225 watt hours at 2:15 in the afternoon. That's fantastic. Hello, and welcome to the day where things start getting real. As they say in the rocket industry, it's all talk until you start bending metal. And that's what we're doing today. I need to fabricable up a bracket that will hold this module onto that balcony railing. And given some quick and dirty measurements, this is what I came up with. The bracket will come down for 3 centimeters, across for 2 millimeters, back up for 3 centimeters, across for 11, down for 4, and back for 2. So what this does is it allows me to position the module in place, drop it on the balcony railing, and then slide it into place, and it will hook here, which will prevent it from falling over. And I will also, there'll be 2 of these, and I'll zip tie the crap out of it to the other balcony iron railings and stuff. So there'll be a bolt going through here, 1 in each bracket. And I thought, all right, I'm just going to go see if I can find a bracket. So I went to my solar company that I bought the module from. This is the only bracket they had. It's stainless steel. It's got to be 4 millimeters thick. It's going to be unbendable, and it's just way overkill for my needs. And it came with 1 bolt each of this style, and this nut is designed to go into their racking system, and this also is designed to fit into their racking system. So that's not going to work. But the module did come with 2 bolts of conventional type with a metric Allen key hole in the top. So I'm going to have to make do with this, or I may actually invest in the proper size, which is just a titch bigger than 7/32. So what I did is I took these measurements and I came up with a paper template, and doing it with one hand, it's going to look like that. So I need to make all these bends. And so let me see how that works out. I'm not Gendry from Game of Thrones, but I'll give it my best shot. Well, as you might have expected, that didn't go well. I got the first two bends for the clip, made this bend, was in the process of making this bend, and this one broke off. And this is the second piece I tried. So we obviously have a flaw in Mikey's technique somehow. But my friend Abel's done this before, and he said that basically you make a bend and then you weld in the reinforcement, make a bend, weld in the reinforcement, and he's got the welder. So I'll head over there tomorrow and we'll see what we can do. Welcome back to a bright sunny morning, but it's December 26th and we just had a solar eclipse come through. Local time started about 10:15, ended just before 2 o'clock. I got a couple of pictures that I'll show you here, and it'll be fun to see how much of an effect that had on the solar collection for today. But I want to jump in and show you, after many days of scratching heads and thinking about how to hang the module out there, my friend and I have come up with this bracket. It is the same shape as my template, but the bends have been welded and reinforced after each weld. We also decided that the U bend right here made everything too weak. So this piece is a flat piece, this piece is a flat piece, and there's another small flat piece in the middle, and that little steel sandwich there is all welded together, and then the module frame slides in here. It's got bolt holes with a nice shiny new drill bit, and there's one and there's two. So let's pop them on the module and see how they look. Okay, let's see how the module goes. So it's right there on the front, and it slides down and it just clears the back, which is good, and there's going to be enough room right there for the bolt head, so that slides down, then goes forward, and it's locked into place. So that works very, very well. I'm going to give you two pieces of advice. Never fight a land war in Asia, and never work on a south-facing balcony in the direct sun in Thailand in the afternoon. But despite all that, the module is installed. Had to do a little drilling and shaping and persuasion on the two brackets, but they are, they are in place, and there are 13 more zip ties all around the periphery holding the whole module in place. It's wired into the inverter, not making any power at about 6 o'clock at night, but we are powered up and monitoring. Let's go take a look and see what it's like from the street. And there it is. There should be no doubt in anyone's mind that there is a solar panel there, right there. Although it doesn't look too bad. I thought it would stand out more, but it almost looks like a blanket hanging over the railing or something, and it's exactly the height of the balcony. Well, if it's not one thing, it's another. The module is out there mechanically hanging from the balcony, but the microinverter stopped outputting any power. We had no indication on the LED, even though the input AC from the disconnect box is good. I have my DC clamp-on meter like this, told me I was getting good DC power or DC current coming through. I disconnected this from the module, measured the voltage. I was getting voltage in the range that it was supposed to be. So I contacted the company at the worst possible time of the year. Like, it was Christmas Eve, I think, was the day I told them that it failed. Today, the day after New Year's, they contacted me back. And after a bit of back and forth, they said, okay, we're going to send you a new one, which is great. Maybe take, I don't know, a week or something. This one came FedEx from China. Okay, kiddies, here we are. This is the old inverter that just failed outright on the afternoon of December 26th. This is the new inverter that was shipped to me. It arrived February 6th. So it took a month and a half for the lovely people to get me a new one. And this sat in a box in a Thai post office depot in Bangkok for 2 weeks until I finally went to the post office and said, "Where's my box?" They said, "Oh, we can't read the address." So I told them exactly where to deliver it. This, I am not kidding you in any way. This is the shipping label. Sorry for the glare. You can see there's something crazy with their printing. They double printed their from address. And look at the to address. It's my name, and then it's covered with a giant barcode. You can almost see the first line of my address right there, covered in a giant barcode. How is anyone on the planet supposed to be able to deliver this package? Anyway, so it arrives on February 6th, and on February 6th, I'm on a train to Penang to go there on a little mini holiday for a week. I got back very, very early this morning, February 13th. I'm waiting for the sun to go down, and now I'm going to wire the new inverter into the meter and disconnect box, set it up at night so that it wakes up gloriously in the morning and starts making electricity. Do you think it's going to work? Yes or no? Welcome to 7 o'clock in the morning, and as you can see by the little blinking red light, we have signs of life on the microinverter. It is just barely dawn. The sun might not be out yet, but we have ambient light. The microinverter is trying to wake up, and it is talking to the solar app that comes with the data box. The data box is here. Sorry for the darkness. It has detected the module. It's making 0 watts, and we're getting communication. It says we're at 21.62 volts DC, but no current flow yet. 201 volts on the output and no current yet. So we are possibly up and running again. Okay, it's now 7:24 a.m. We're solid green light here. We're starting to make some reliable power. The microinverter is right now putting out 3.83 watts DC, just 2.25 watts AC. And we can see on the big chart, 2 watts, and it's starting to build a histogram. We're sitting about 2 watts. My power meter over here is reading 4 watts, 6 watts, 3 watts, bounces around a bit. But the cool thing is through my node red, where I'm capturing the raw power being read by that power meter, I run it through some reformatting, and then I decide if the time is between 7 a.m. and 7 p.m. That's really the only active solar hours. If that is true, I create an SQL statement and store the data in my database, and I am actually seeing that come through. So let's look here. So the power meter for unit 116, which is the one that's running right now, we got an event. It is between 7 and 7, so I'm pushing the log to the server, and I'm writing in unit 116, 230 volts, 0.054 amps, or 5 watts. And if I come over to my solar display, I am now showing 5 watts of active power. So we are up and running, and we're making power again on February 14th. So the last working day was Boxing Day, and now we're running again on Valentine's Day, and this makes my heart very warm and fuzzy. It is now 11:30 a.m. and the sun has just completely have access to the front of the module. I've actually intentionally shifted the module to that side because the sun in the morning is weaker and I want to catch as much as possible in the late afternoon. We're now doing 70-ish watts, depending. I can see my power meter is bouncing around a lot, 81, and it dropped down to 23, back up to 60, up to 90. So I'm getting a lot of bounce on that. But if we look at the output today, right now we're doing 81 watts. My best day ever at 11:30 in the morning was 17 watts. So we are way ahead on the curve. We are way up here on the curve, and I expect we're going to make a substantial jump up here and then slowly trail off in the afternoon. Okay, I had to pop out, but I'm back. It's 3 o'clock in the afternoon now, and strangely enough, I went and test drove an MG electric car, but more on the video and that later. But we appear to be at kind of solar production maximum. We're at 110 watts. The curve has gone like this, and we hit 117 on my system. I'm showing 113, and the curve is similar. Unfortunately, with the system that's not yet set up, it's giving me a 0 reading every 5 minutes, so that's why this is going crazy. But we're almost at 1/2 of a kilowatt hour, 476, and over here it's 460, so we're quite close in our measurements. Cross your fingers that I get a full kilowatt hour out of my one module for the day. I've probably got a good 2.5 to 2 3/4 of direct sun, powerful afternoon sun. We'll see how that goes. Okay, it's 5:38 in the afternoon, and our production has fallen off the cliff because we're not getting sun on the full right-hand side of the module because of this stupid little decorative thing hanging off the side of the building. So let's go see what our charts and graphs look like. We're down to 11 watts or 6.81 watts depending on who you look at. I've got a nice curve, and then it falls off really dramatically because of that, which is also shown here. I wonder if it might make more sense to pull this over and get more morning sun, or push it all the way over and get more afternoon sun. But hey, we can experiment with that. And then when my order for the second module and the second microinverter come for the new unit condo that I just bought next door, I'll be making twice as much power. And I made 640 watt hours today. And that basically will power that TV for 6 hours and 40 minutes, which is not bad. Knocks off some of my aircon bills, some of my computer electricity bill, various other electricity consuming devices. And right at the end of the day, if you look at lifetime generation, we're at 642 watt hours today. My best ever was 310. So hanging it off the front of the balcony has doubled my total power generation. And if you look at, this was the best day, very peaky. And now we have a nice bell curve, as we would expect for a normal solar power system at somebody's house. Okay, so I want to give you an overview of my finalized solar capture monitoring system. It's all on this web page, and it's pulling the data from the Sonoff device, running Tasmota software, sends through MQTT to my Mosquito broker in Singapore, which is also running Node-RED, which wires all the events together, writes the data into a MySQL database, which is then retrieved with PHP and JavaScript and displays in Google Charts. Now, if that's not a DIY software setup, I don't know what is. But so here's our two instantaneous gauges. 115 is not up and running yet. 116, we're sitting at 84 watts right now, which is shown here. Today we've made 406 watt hours total. This is the graph for today showing the 116 production. 115 is down here because we haven't made anything yet. We peaked at 101 watts. This chart we can pick any day in the past, and it will pull it back up, and we can see the output for the whole day based on the microinverter in question. Now if I scroll a little farther, I can see the last 7 days, each day as a bar chart with total system production. Yesterday was really cloudy, didn't rain, but it was very cloudy. Today has not been great so far. And then down here is total lifetime power, almost 7 kilowatt hours. You can see the gap between December 26th and February 14th when the microinverter was dead. And you can see the different tests I did. This is flat, 12 degrees, 39 degrees, and vertical. You can see the very dramatic difference there, and I'll show you that in a graph in a minute. So that about wraps it up for the solar software. Okay, to really wrap things up, I think I should go through and show you the results of all of these experiments that I've been running. So as you can see in the first graph, this was the profile when we were sitting flat on the balcony on December 13th. We had a very, very flat power line, and then it shot up when the entire module was in the sun, and then it just plummeted right down again, back down to zero. We peaked at 80 watts. This is obviously not the way we want to go. The next graph was at 12 degrees, and we got a little bit better. We peaked up at just over 100, but it's a very narrow power generation band. So again, not great. Move to the next graph. On December 21st, that was our 39 degree one, and this looks a lot more like a normal solar power system, waking up in the morning and then the start of a bell curve, and then it we peaked at around 118, and then it dropped very dramatically because of the shading from that decorative brown thing on the right hand side. So this is obviously not good either. We on December 26th, right here at about 4 in the afternoon, you can see where the inverter failed, just died, boom, down to zero, never came back to life. And then on February 16th was our vertical test, our best day so far in the vertical orientation, and this is really much more what we're looking for. We start making serious power about 10:30 in the morning. We peaked at 117, and then we gradually came down a little bit in the late afternoon. It's about the best I can do until I make a new set of mounting brackets that will push the module farther away from the railing so that I'm not blocked from the shade from the right or the left. But that's a bit of an engineering exercise that I can do at my leisure. Anyway, I hope this was vaguely interesting, showing the different stages that you can make with your different solar orientations on a very space-constrained single module system, soon to be a 2-module system. And I appreciate your time just to watch me go through all of this. So, thanks again. Bye. Welcome, people who stayed to the end of this exciting video. I just want to let you know I've had a bit of an epiphany about YouTube, and it makes me sad. I've been asking people to subscribe to my channel and click the like button in the hopes that YouTube would recognize my channel and kick in a little ad revenue for all these goodies that I'm buying to help me with my little projects. And I realize it's all in vain. YouTube is caring less and less about the people who use its channel. Even the big boys and the big girls are having to go to something like Patreon for financial support, and I'm just not worthy of a Patreon following for anybody. So if you've enjoyed my stuff and you want to see more of it, go ahead and click subscribe and like if you like. Otherwise, just enjoy this picture of my beach here in Thailand and enjoy the rest of your day, and I thank you very much.